Thanks very much, Frank. And it was lovely to see some of the figures that Jim shared early on, because I remember them well, and the trouble we went through with them at the time. So I'm going to kind of bring things down to a national context, national level. And in terms of what we're going to cover, I'll mention very briefly the Special Report on Climate Change and Land again. I'll sort of focus in on a few of the things that I think are particularly important with regards where we're at with our land system in Ireland at the moment and where we need to get to. I'll then talk about a piece of work that followed that, where we translated some of the key findings into an Irish context, and again we looked at those response options that Jim talked about in some detail. And finally I'll finish by looking at some more recent work where we looked at fluxes, scenarios and capacity, and this idea of the need for an integrated approach to land management to sort of minimise negatives and maximise positive synergies where we can. So if you're not familiar with the report, Jim obviously gave a wonderful introduction to this earlier. I think it's a really useful resource for anyone interested in the complexities of the land climate system, and the authors went to great pains to make it accessible as much as is possible in this type of report. So it's a really useful resource. The integrated response options are something that were particularly interesting when we translated this into an Irish context later. And then more recently, we've looked at trajectories for land use change in Ireland, and that links as well to the global picture that was analysed in more detail in this report as well. And to mention, there was a whole chapter looking at socioeconomic dimensions, including the need for just transitions and societal partnerships, also really important. Here is the figure again, which Jim thankfully has already explained, so I don't have to go to the trouble of doing that. I've kept it small on purpose, so that it's more about the colours really, and the blue being positive here in terms of the response options. And it also shows the breadth of work, I think, that the authors undertook in this assessment. They looked at 40 options, and this type of integrated analysis is really difficult to do. So they were looking at mitigation, adaptation, land degradation, food security and desertification. They also, for each of these options, looked at uncertainties around the potentials for mitigation, for example, which is really important and really useful to have that level of information. And then some of the options were dealt with separately, those options that result in competition for land. And I think in particular afforestation there is particularly relevant for us here in Ireland and how we scale up, if we are to scale up our forestry, how we do that in a sustainable way, and it's going to be really challenging. But the main story really is that it's very positive, and many of these actions are synergistic across multiple targets, which is really a good news story. Another figure from the report, the special report, looked at land use change out to the end of the century. So what you have here are on your y-axis you have change in land use in millions of square kilometres, so potentially vast areas. It's really large. It's difficult to get your head around that level of change we're looking at. And the baseline 2010, and then the lines represent change relative to that. And under this particular scenario, the land use change is compatible with limiting warming to 1.5 degrees Celsius globally, and it's a sustainability-focused pathway. We looked at different pathways in the report. This is just one that I've chosen as an example, really. Probably the best case scenario many people would think. There's 2 points I want to make about this figure, or to draw your attention to. Firstly is the really large increase in forestry and bioenergy cropland in blue and purple there by the end of the century. So many millions of square kilometres additional forestry and bioenergy. On the other hand, you'll see commensurate decreases in pasture land and cropland. That land has to come from somewhere to go into forestry, so we're seeing less pasture land and cropland globally. And yet at the same time, under this analysis, we were still able to meet the needs of food production. And that's through intensification in some cases of agriculture, and also changes in consumption patterns as well. So there's a lot of complexity behind a figure like this, but I think the key message I wanted to get across to you from this is that the changes we face in Ireland in terms of land use are not unique. There's a global issue here around land use and getting to a sustainable level of land use. So we're not alone in that challenge we face. So this report really was sort of a translation, climate change and land use in Ireland. It was part of the EPA funded and Department of Agriculture co-funded fellowship that I had at the time. And this tried to translate some of those high-level findings from the special report into an Irish context, sort of downscaling, if you want to look at it in that way. So it looked at current state of land use, for example, looked at greenhouse gas emissions with a breakdown by the greenhouse gases. But the largest part of the report really was dedicated to looking at those options from the large table that we've just seen and seeing how applicable they would be to Ireland and how might they be rolled out, what are the barriers to their implementation and so on. So really from that I just wanted to focus on the 12 options that came up as having the highest potential. And I should say that this was a fairly high level assessment. It's focused on adaptation mitigation only. Didn't look at food security, for example. That wasn't possible in this case. So you'll see there's 12 options there into different categories. We have things around demand management, so dietary change mentioned already. Agricultural land management, so increased productivity, improved grazing and cropland management. Afforestation is in there. Restoration or reduced use of peatlands is in there, is really important. So these are the 12 options that came up as having the greatest potential impact for our land system. That's not to say many of the options that came up as having moderate applicability are also really important, particularly for adaptation, which may apply in some cases to relatively small areas. So if we think about landslides as an example, but where they occur can be really, really serious and detrimental. So there's sort of a caveat there with that. In terms of the options, many of them do face considerable barriers to their implementation and rollout. So if we take, for example, improved grazing land management, that may require at farm level significant investment in new technologies, better ways of applying slurry, for example, different formulations of chemical fertilizers. That costs money. And where it costs a lot of money in terms of investment, that may be beyond the reach of many small and medium farm enterprises. So I think there's work to be done in that area to improve uptake. And then if we look at things like agricultural diversification, that's one, it's interesting in that it's not likely to do an awful lot in terms of mitigation, but more on the adaptation side. And this speaks to another point here, that we have to be careful in terms of what we expect to get back from these actions. Some will deliver more for mitigation, some more for adaptation. And it's just about accounting for that and how we plan to roll them out. So in the case of agroforestry, it's a really interesting one that can deliver for both mitigation and adaptation, which is pretty unique. And then I suppose the final point on this would be to say how these things are actually implemented has a big impact on the overall sustainability. So two areas of afforestation might be very different in terms of how they're actually carried out on the ground and managed and so on. So that's quite important as well. So moving on to more recent piece of work with colleagues in University of Galway and Trinity College. So this Flux of Scenarios and Capacity report with 6 chapters. We looked at land use, land cover, greenhouse gas fluxes. We looked at climate change impacts on the land system and future impacts. We looked at land use change scenarios related to net zero. We also looked at the impacts of land use change on other things, which in this case we focused on biodiversity and water quality. And then in the final chapter, we looked at how this interacts with policy. So I'm just going to take a few very small pieces from a couple of these chapters to sort of give you an indication of what's in the report. Obviously, much more detail in the report itself. In terms of land use and land cover, so we did a little bit of work on this. At the time of writing, the Korean dataset was the best available. It's fantastic to know that since then we have a far higher resolution dataset available now, which is fantastic and a great advance. But essentially, this analysis took the categorization we used in the special report and sort of converted that as best possible into the Korean classification system. And you'll see here a regional breakdown of those different land cover classes. So there's a few takeaways from this table. I don't expect you to read all the numbers, but the key takeaway really would be that unsurprisingly, the distribution of our land in Ireland is not even, but particularly for certain types of land. So for wetlands, including peatland, we have a lot more in the west and border regions, for example. Whereas cropland, on the other hand, we have much more of that in the east and southeast. So you might say, so what? We sort of know that already. But in terms of how actions are implemented for climate mitigation and adaptation, this is actually quite important, I think, because the actions we take may have disproportionate impacts on different regions and the communities in those regions. So this is just something that, and particularly as well around biodiversity, actually, I should say, that much of our high nature value grasslands, or sometimes referred to as marginal grasslands, are in the border west, midwest, southwest regions. So if we take actions that result in afforestation of those grassland areas, we could have a really serious impact on biodiversity, for example. But with the new availability of better resolution data, I think there's a lot of hope for improvements in how those things are managed. We also looked at the impacts of climate change in Ireland using the latest data that was available, scaled down data. So the key message, I suppose, in terms of observations is that observed changes to our climate system have already happened, and they're already having an impact on the functioning of our land system. So this isn't something for the future. It's happening already. So for example, we have an increasing trend in winter rainfall and decreased trend in summer rainfall, for example, which would impact the growing season as an example. And we've also had pretty severe soil moisture deficits or droughts in the last number of years, which have impacted the agriculture sector. In terms of the projections, not really going to dwell on the detail here other than to say we're definitely going to see increases in temperature. It's all about the magnitude. Heat waves are predicted to increase, particularly in the southeast. We're expecting to see a large decline in the number of frost days annually. So this is really going to impact our ecosystems and our agriculture sector and forestry as well. So we're going to have an increased length of our growing season, but clouding the waters a little bit will be an increase at the same time in extreme events and droughts. So although that season may be longer, it will be more unpredictable. And that will pose new challenges in terms of adaptation. And I think the important thing really is when we think about actions, to think about how those actions will improve resilience going out to the middle of the century and beyond. We looked at greenhouse gas fluxes, and the presentation from Mary Frances explained LULUCF in great detail. In this case, and I'm trying to avoid yet another acronym, but we've combined LULUCF and agriculture in this particular analysis. And the reason for that is that this AFLU category, agriculture, forestry and other land use, it's sort of the approach as well that was taken in the IPCC special report on climate change and land. It's more relevant, I would say, to how land is managed in practice. So the same unit of land, in this case, where fertilizer is applied, that will be under agricultural soils, whereas the carbon sequestered in that grassland would be under LULUCF. So it's very important in terms of accounting that those systems are as they are, and there are reasons for that. But I think in terms of how land is managed, it's much easier to explain this to stakeholders. Anyhow, the takeaway from this slide is very simple. When we combine these categories, there's a very significant net source of emissions at the moment. Okay, and you can see forestry and harvested wood products is the only significant sink there that we have in the categories. The largest source of emissions would be the enteric fermentation, followed by the grassland category. The grassland category, obviously, just to say that's the organic soils that is driving that particular source of emissions really there. And the other thing to think about, if we talk about the future then and getting to net zero, we're essentially trying to get a situation where this is balanced, so the emissions would be balanced above and below that line. So you can see it is going to be really challenging. There's no getting away from that fact. That's not to say it's impossible. Many actions, as we've just seen, are available and can make an important contribution to achieving that. But it's not going to be an easy transition, and it's going to require a lot of change. So in a separate analysis in that report, we looked at some scenarios for net zero AFLU by 2050. So essentially, if we tried to balance the books in terms of the previous slide in that graph, what would that look like? Now, this is, we were limited, I suppose, a little bit in terms of time and available data. So the approach we took was to have some simplified scenarios, I would call them, that were agreed with the stakeholders involved in that particular project. And they looked at afforestation, peatland restoration, what we called agricultural optimization, so increases in production efficiency and changes to the livestock numbers, and then combinations of all of those, and then some additional scenarios looking at more room for nature, more room for bioenergy production, and more room for cropland. And we used the best available data we had at the time. So the outcome from that, and I'll just explain what this figure is showing. So essentially what you have here is the zero represents where we want to get to. We want to have a balance above and below that line to get to net zero. The black dot, if you can see it on the bars there, represents the balance. So there's only one of these that have sort of attained that net zero by 2050 target that we had set. And that particular scenario was S4D, and in that case we'd combined the actions for afforestation, for peatland restoration, and for agricultural optimization at their highest levels that we looked at. And only by combining all of those really ambitious actions could you get there. And I suppose that's the takeaway message. So it is particularly challenging. And we are talking about really, really large areas of afforestation there in that. Obviously, there's a lot more detail about those scenarios in the report. I would say they're really a starting point and a first iteration. And I would hope future work will bring more nuance to this, will bring in more actions and options. So things like agroforestry that we know has great potential, that could be built in there as an action. We also looked then at, because those areas of land use change were so large, what impact would they have on biodiversity and water quality, and what sort of synergies or trade-offs might there be? So this table, the pluses here are where we have, we expect positive interactions, and the negatives, obviously negative interactions. So some actions have the potential to impact negatively. For example, if we have increasing livestock densities, why might that be the case? Well, the fact is, if we increase our forestry at such a large rate, we'll have a lot less grassland, so that might require more intensification of the remaining grassland. So it's a little bit counterintuitive, but that type of nuance is important because that could impact water quality and biodiversity. Other options are generally synergistic. So peatland restoration, for example, is expected to be positive for adaptation in terms of water storage and regulation, and also in terms of biodiversity. So that's sort of positive, expected to be positive across the categories we assessed. And really importantly from this, to maximize the synergies and minimize the trade-offs, we do need some targeting of those actions. And that's going to be challenging. And we have to consider the capacity of the land. So different soils have different capacities for different functions. And taking that into account is important. So a few concluding comments then. So the land system can play an important role in meeting the objectives we have in terms of mitigation, in terms of how we need to adapt. But there are limits to what it can do. And I think it's important to recognize those and to think about them in terms of the targets that we have and will have going into the future. When we have actions targeted at mitigation and adaptation, we do need an integrated approach to how they're rolled out in practice, or we could have unintended negative consequences for biodiversity and water quality. So a good example, I think, is the grasslands that are managed extensively at the moment in Ireland have most of the biodiversity rich grasslands in the country in them, or probably all of them. Those lands, left to economic drivers alone, will be quite vulnerable to afforestation, for example. So how do we balance that? That's going to be a real challenge. The other thing is that climate change is happening at the same time. So we're going to have feedbacks from that into our land system. So when we think about how our peatlands function currently, by 2050, we're going to have many more droughts, we're going to have higher summer temperatures. That may lead those systems to behave differently, and maybe, well, it's actually likely they won't store their carbon as efficiently, for example. So that we need to sort of try and build that in, if possible. And the very final point really is that, and this is where the train tracks come in, I think we lack at the moment a shared vision for how our landscapes will look in the future. So we don't know what's at the end of those train tracks, and it's very difficult to encourage communities and people to get on board that journey if they don't know where the destination is. Obviously that's a pretty tall order to come up with that solution, but I think that's one we all have to try and aim for. And with that, thanks very much for your attention.
Great, thanks very much, Eamon. And I think what you showed there as well is the importance of, I suppose, how we can bring the knowledge from the IPCC and localise it. And it's important that we do localise it and show how it can, I suppose, inform what we're doing here. And you also teed up nicely the next presentation in terms of you were highlighting the need to improve our detailed understanding of land issues, and the new National Land Cover Map is a topic for the next conversation, and it's a two-header. It's from Rachel Kelly from Tailteann, formerly, at least partly, OSI, and Gavin Smith from the EPA. And this shows that this land cover and land mapping issue is really a national issue. It's not just for one agency. So I'll hand over to Rachel to get us going, and Gavin will then take over. Thank you.
Brilliant. Thanks, Frank. I'm probably the last speaker that can say good morning. My name is Rachel Kelly, and I'm from Tailteann and formerly OSI, and I'm here to present on the new National Land Cover Map. It's the first iteration from 2018, and it was delivered in partnership with the EPA. That's just a screen grab of it there, and I'll talk you through how we actually achieved it. So this was very much a public-partner relationship, but it was done through the support of the members of the National Technical Working Group. It was a cross-governmental group. Some of the key members are shown here: DAFM, MPWS, Teagasc, and thank you very much for all their help. We also worked really closely with Beck Ecological Consultants. We are a national mapping agency, so we took the support of the ecological knowledge to produce the best map that we possibly could. This is long in the making, over 10 years, and Tailteann took on board this project in around April 2018, just to give you the scope of how long it took us to achieve this. So just from the outset, I'd just like to point out the difference between land cover and land use. They're often interchangeable, but there is some stark differences between the two. So in essence, land cover is not land use. Land cover refers to what is physically present on the Earth's surface, and land use is the human activity at that particular location. So just some kind of easy to understand examples. For land cover, we assign a singular classification or a single label to each feature on the Earth's surface. For example, a building. Land use at that particular location of a building could be residential, commercial, industrial. Same way with forest. We map the different types of forests: broadleaf, coniferous, but land use would say whether it's a commercial forestry or recreational area, for example. So once we now understand what I mean when I'm referring to land cover, it's kind of good to understand why we needed a new land cover map. Everybody is aware of what was currently there beforehand, COREEN, which is their pan-European land cover map. So I've just taken an example here of this COREEN land cover data for Johnstown Castle, the EPA headquarters. I'm sure everybody's familiar with it. And the scope of this area only has 4 classes, so 4 different classifications. And just to highlight, the red area at the top is a cultivated land or a cropland that wasn't captured because COREEN's resolution is 25 hectares. So once we understand that there was a need for a new data set, we started and began making a new land cover map. And I'll take you on the journey of how we got there. There's 7 main key areas that we have to touch on in order to produce such a map. And the very first one is classifying land. So what do we actually want to achieve? Everybody's aware that Ireland has numerous different shades of green, and we had to assign a class or a label for each of these features. And we came up with the new National Land Cover classification system. Essentially, it's a label that we had to assign for each of the features that you can see in our imagery. So we did extensive research looking at what our counterparts in the EU did and national vegetation and habitat classifications. We again did quite a lot of consultation with our stakeholders. We carried out a stakeholder survey, got over 100 responses back in 2016 in order to come up with our 2-tier hierarchical classification structure. Very simply, it comprises of 2 different levels. Level 2 is the most detailed. It has 36 classes in it, so every single feature you see in an image has to be slotted into one of these classifications. So once we have that mapped and defined, we are able to come up then with a higher level, which we can aggregate up, which is known as level 1, and there's only 7 classes in this section. So once we now know what we're targeting, what we actually want to map, we had to do an extensive data collection. Just to point out that our reference year for this is 2018, so the map refers to what's physically on the ground in 2018, not now in 2023. So we gathered a wide variety of input data. Our aerial imagery, we used satellite imagery under the Copernicus program, digital surface models, which are our height data, so we're able to tell the height of particular features that can be seen in our image. And Prime 2 is Taoiseach Éireann's spatial database. It's a seamless database of over 50 million features that we were able to harness and utilise. And then we took data from some of our stakeholders, LIPIS data from the Department of Agriculture and forest data from Coillte, as well as habitat data from a wide range of local authorities. And thanks very much for their support. Just this kind of shows the breakdown of our working units. This is just to highlight the kind of extensive workload and processing that was needed to achieve this map. And again, we were able to send this out for validation, and Gavin will kind of go through that in a bit more detail. So this map was achieved through remote sensing. So it was mapped from a distance, looking at aerial imagery and combining aerial imagery with known data sets that are out there. So very simply, we took a wide range of data sets, stacked them on top of each other, and then we were able to do a deep dive down through the data stack to collect different data and information from all the different layers to come up with a most likely classification for that particular parcel. Here, this is a bit techy, but it just is overlaying our Prime 2 database over our imagery and how we kind of came about this through machine learning. You have to segment down, so this is us doing a deep dive, trying to gather our information. We assign then through rules what an actual feature is that we most likely think it to be. And then through numerous iterations of this, we come up with a known classification. So there you can see we've been able to pick out the different types of grassland, where the bogs are, different types of bogs, where they stop and start, as well as the vegetation, and split that out between scrub and different types of forestry. Then we come up with our post-processing. The output, it's an imagery classification. It's quite unrefined. It wouldn't be the nicest looking. So we take that raw output, run it through post-processing, and come up with a nice, pretty map that is smooth and generalised and removes the noise that we no longer want. So this is kind of the final product. Mary Frances gave a sneak preview of this in her presentation. Again, this is the same area that I was referring to earlier, just to highlight the red area that wasn't in Careen. The black area beneath that further south is a lake, and the forest was also not picked up. So now we are able to, through our classification system, be able to produce a new national land cover map that is 250 times more detailed than Careen. And then you can just see here the different labels that we've been able to assign. So just to kind of show again, there's 4 different kind of polygons or features according to Careen, and the number that we are able to achieve now. And then this is just a final example of the output. This is just to highlight the delineation that we've been able to achieve, the cultivated land on the left. We were able to pick that out and pick out the hedgerows and map the hedgerows and tree lines that fall within inside the parcels. And again, just showing the different types of grassland that we've been able to achieve. So now we know where everything is. It's mapped accurately, which Gavin will speak about. Now we'll be able to monitor and preserve that going forward, because this is the first iteration, we hope, of many. As we capture our imagery through our national imagery programme, every 3 years we should be able to feed in that new imagery and produce a new map every 3 years. So,
Thanks, Rachel. So I'm going to cover the validation side of the map. So it's all well and good having a map, but it's important to know how good that map is in terms of its uses in application in the likes of land activities. So first of all, we went through an extensive process with the CSO and stakeholders on how we would go about actually validating the maps. So we came up with a process where we had very random stratified samples across the country. We would get independent assessment of those samples. We put into that a common set of data. So the idea of that was that everyone would sample that data, and then we could see that there was consistency in terms of the approach of the validation. We would validate the whole object that we were seeing in front of us, and we'd validate it based on its thematic accuracy, which is the class that we've assigned correct, and then the boundary, how accurate is the boundary that has been delineated from the map. And then we could get general feedback from the people who are doing the validation. So it's really, I suppose, it'd be remiss of me not to thank the efforts from the people involved in the project. We had basically no one really on the project did any validation. It was totally independent of the project. And we had the CSO, Department of Agriculture, Chagas, MPWS, Beck Consultants, Atlantic University, and some people within the EPA do the actual validation. And what they covered was a huge number of samples across the whole country. So 56 validators went in and they validated over 22 samples across Ireland. So what they did was they just looked at what we were saying it was off the images and said whether they agreed with that or not. 1,600 or so were common points, which everybody did. And then overall, that was 28,000 assessments across the data set. So really a very extensive assessment of the data set. And the good thing about all of this was that these graphs here, what they show is across the common data set, how the organizations performed. And what we're seeing is that they consistently assess the data in the same way, and they came up with largely the same results. So that's what their performance was against the actual common points. So we know that the data across the board is quite consistent. So to move on to the accuracy and definitions of how accurate the data set is, and we now know, so often we produce a map, but we wouldn't get this level of validation in it. So we now know how accurate this data set is. So when you group all the classes together and all the samples together and across the board, the overall accuracy of the data set at a thematic level, the blue bar on the top is your level 2, which Rachel explained earlier, is the more detailed classification, and then the green one below it is the level 1. So we get a slightly higher accuracy in the level 1 because essentially classes within, say, grassland that might be misclassified between each other. When you go to the level 1, they're both the same level 1 class. Okay, so ultimately within the project, we'd set ourselves a target of kind of 75 to 80% accuracy across the data set, and ultimately we hit that. That the line there on the screen is a 75% accuracy line. So we're above it in all cases at the overall accuracy. And then on a geometric level, they're both identical because effectively the same objects were looked at, whether it was level 1 or level 2. It's an 87% accuracy on the map. But the detail, like a general stat is all fine, but what we actually have with all this data is we can go to each individual class, and again at the thematic level we've got here, you can see each of the classes, how they perform in terms of accuracy. So again, I've put in a line here at 75%, which you can see, and you can see that some of the classes actually fall below the 75%. Okay, so I'll just highlight them there. So what we have is we've some above and we've some below. Okay, and the important thing here is that we can still use the data if it's below, because essentially we can see, okay, that data is maybe 60% correct. I can use it with that information and use it appropriately and not make too many assumptions about how accurate the data is. Or I can bring my own data in to complement that. But essentially what we saw was that even if it was at a low level, it was consistently low across the country. So it was effectively, we knew that class is an area where we can improve in the future. And then on geometric level, I won't go through this, but largely on the geometric level, we performed above the standard across the board on all the classes. So ultimately, we know now that the map is largely accurate, and we know where and when it's not. So that's useful in terms of the application of the data. But then what does that mean in terms of national statistics? So what I'm going to show you here is the comparison of the 2018 National Land Cover Map and the equivalent map in Korean, which is 2018 as well. And what I'm not presenting here today is change. It's actually a change in perspective. So we now have extra detail. So it's really identifying what the extra detail tells us about land in Ireland. So the first two things I'm going to show you is grassland and peatlands. So there's a reduction in terms of the statistics in grassland. So this is effectively, we saw there that the croplands Rachel identified. Previously that would have been called grasslands. Now it's actually called grass, or it's now called cultivated land. So it's actually moved out of that class. It doesn't mean that it's actually changed. It's just actually we now have more detailed data to say that it is actually cropland. On the peatland side, I'm going to actually come back to that. It's a little bit more complex. That looks like a fairly drastic figure, but essentially we were mapping land cover. So when we looked down, we would see what was actually there. So it might have been forest on a peatland, grass on a peatland, or whatever it be. Peatlands cover more than just the cover, they're the soil as well. So I'll come back to that in a minute. And then where do we see the increases? So we've a lot more in terms of forestry. So a lot of forest areas that wouldn't have been identified previously are now actually in the statistics here. The cultivated land has gone up again. That example that Rachel showed is good for that. And then the heath. So on the heath side, a lot of the kind of peat orientated classes would have gone into heath. And then an interesting one is artificial. So it looks like it's low, but it's actually, in a percentage of itself, it's probably 100% increase in artificial in terms of what we actually would have recognised before, because most artificial surfaces are below 25 hectares in Korea. And then the last thing just on the statistics is the top, here in the statistics you can see that the top four classes, which is improved grass, wetland grass, cultivated land, forestry, or traditional forestry and coniferous, covers 66% of the national area. This is all presented in a report on Taoiseach Éireann's website, which is the final report from the project as well. And just briefly to come back to the comparison of peatlands, what we see here is this was the statistic that was down 7%, so we had 6.5% peatlands. There's a distribution of peatlands in the map there, but ultimately this is an example of how that actually changed. So the yellow outline is Careen, and when we bring it in, this is the national land cover, which is in black, and what that's showing is that what we would have previously called peat, we now might call something like transitional forest, or it might be down as a grassland or scrub or whatever it actually be. But that doesn't mean that it's not actually on a peat soil. So it's a statistic of what we can see from the surface or from the air. And just quickly some use cases. So we've already used it in the noise mapping activities where we can assign absorption or deflection rates from in the noise models. Oops, apologies. Mary Frances mentioned the LULUCF, so we started to use this data in LULUCF to fill gaps and to audit the data that we have in it. So basically what we try and do is we combine all the different types of data sets over many different years. And what the Land Cover project at the moment is doing is it's filling the gap of data gaps in 2018. But if this data set becomes online every 3-4 years, we'll actually be able to bring it into the LULUCF process more consistently, and then that will report on into the National Inventories report. This is just an example of the data when it's actually processed. And then the final one is we under the land use review evidence activity last year, we tried to take the National Land Cover map and produce a land use map from it. Okay, so what we did is we took all the objects in the land cover map and we tried to cross-reference them with use data sets and assign a land use class. And what that showed us is we could go so far, but we had an awful lot of gaps in terms of information, and we couldn't actually map land use without additional information. So really, that's a work in progress, and one of the recommendations under the synthesis report was more spatial data to allow us to produce better land use maps. I'm just going to hand back to Rachel to summarise the final slide.
So just a quick brief summary. This is a new product to launch in March. It is based on 2018, plus or minus a year. This is just due to data collection. We couldn't get all our input data as 2018. Just again, highlight it's not recent. We do have our national map, which would give more up to date in the settlement areas if people were particularly interested in that. The National Mapping Division of Táilteann Éireann will maintain this land cover information now that we've started it, and it'll be updated in line with our national imagery capture programme, roughly on a 3-year cycle. We capture a third of the country every year, flying out of Shannon. The map contains known errors, as Gavin spoke about, so never take the results as absolute facts. We do have really good documentation, which I'd encourage everybody to read in order to get to know the data and then understand how you could apply it. And how we think it would mainly help is through catchment management, LULUCF, which has been spoken about already, biodiversity and ecosystem accounting, and hopefully as more and more iterations come of the land cover map, this would just increase its value. And then this is just some quick information on where to get access to the actual data set itself. Any questions or hopefully they're answered on our website, but there's an email address there if anybody has any further questions. Thank you very much.
Great, thank you very much, Rachel and Gavin. That shows an amazing progress that has been made. The importance of making that progress is obviously evident as well, and it's makes the future, makes planning for the future and implementation of policy more potentially better targeted, as Eamon has pointed out. Our next speaker, we're now going underground, so to speak. We're going to look at the National Agricultural Soil Carbon Observatory, or NASCO as it's known. And we have Dr. Rachel Murphy, who's a carbon sequestration specialist from Teagasc, who's going to talk to us about that. And just to remind you, the biogs and all the information about the speakers is available from the QR code if you want to get more details about their expertise. So Rachel, Rachel, thank you.
Hello folks, thank you Frank for that introduction. So as Frank just said there, I'm going to talk to you about Ireland's very recent carbon monitoring network, the National Agricultural Soil Carbon Observatory. So just as a wee overview of what the next 20 minutes is going to entail. So I'm going to talk a little bit about the current state of our knowledge with the inventory, not too much as this has kind of been covered already in this morning's talks. A little bit about the gaps and challenges, particularly around carbon sequestration, around how we measure this and how that kind of feeds into what NASCO is trying to achieve. So we've already heard a lot this morning about the LULUCF emissions. So in the interest of time, I'm not going to spend too long on this. I'm just going to focus on our grasslands. So often when we think of grasslands, we think of these like lush green pastures, and we might presume that they're actually quite strong carbon sinks. But the reality is that they currently are projected to be a large source of carbon at about 7 million tonnes of CO2. And when we're talking about grasslands, we really need to think about them in terms of grasslands that are on mineral soils and grasslands that are on organic soils. So on our mineral soils, we're estimating that approximately 0.5 tonne of carbon per hectare is being sequestered in these pastures. And when we scale this up to the amount of grasslands that we have in Ireland, about 4 million, we're estimating that our grasslands and mineral soils are sequestering about 2 million tonnes of carbon per hectare. So it's really, when we think then of our grasslands that are on peat soils, they really represent a large source of carbon. This has kind of been previously mentioned by Eamon's talk. And in our inventory, we've estimated that our grasslands on peat soils actually emit about 9 million tonnes of CO2. And this is because they've been drained and the really rich carbon stocks in these systems become exposed to oxygen, they become more easily decomposed, thus releasing CO2 from the soils to the atmosphere. But these values are based on Tier 1 default emission factors, and they're not actually representative of Irish systems, of Irish management, and of the Irish climate. And so what we really need is measured data from these systems that actually represents the Irish landscape. So what are the challenges then, and I suppose the opportunities that are present for Ireland? The challenge is, of course, our emission reduction targets. So we need to reduce our national greenhouse gas emissions by 51% by 2030 and really achieve net neutrality by 2050. But the opportunity is that our carbon sinks that contribute to greenhouse gas emissions from the LULUCF sector can be used to help us meet our emission reduction targets for the period that we're currently in, 2021 to 2030. So that means that we really need to understand and know how much carbon is in our agricultural soils and what are the management practices that kind of influence that. So just a little bit then on what carbon sequestration actually is. So when we're talking about carbon sequestration, we're talking about capturing carbon dioxide from the atmosphere and storing it in vegetation or in soils. So where our pastures are capturing more carbon than they're releasing, we refer to these systems as carbon sinks. And where our systems are releasing more carbon than they're capturing, we refer to these systems as carbon sources. So carbon sequestration is really like a win-win for everyone, because carbon that's stored in soils, which is referred to as soil organic carbon, improves the workability of the soils, the soil health, the biodiversity of the soils, and so it's good for pasture productivity. But it's also good because we're taking CO2 from the atmosphere and we're storing it somewhere else, and so we're mitigating against global warming. So it's a win-win. But what are the different factors that affect our carbon sequestration? So there's three main things. There's the type of soil that you have, there's the weather or the long-term climate that you'll have, and there's the land use or the management. So when we're thinking about the soil type, we can look at maybe three soil types. So we have sandy soils, which have a really high potential for CO2 uptake, but they also have high potential for CO2 loss because the particles are quite large, so they're not as good at holding carbon. And so this is kind of like a sink that's overfilling with water. We have clay soils, which have a far higher CO2 uptake, and typically we only really see loss from clay soils if we have a system change, a land use change, and they're very good at binding carbon to the soil matrix. And so this is quite similar to a bath in terms of its potential for sequestering carbon. And then we have a real big baller, which is peat soils. So where the CO2 uptake is low because these soils are typically under anaerobic conditions, they have a certain degree of waterlog with them, so they don't necessarily lose carbon because they're under anaerobic conditions, and so they build and they store carbon over time, and this is equivalent to maybe like a pool. Another way in which carbon sequestration will vary will depend on the land use of the land management. So it's important to note that our pastures aren't just constantly sequestering carbon, that it's very reversible and they're quite fickle systems. So you could have a permanent pasture that has reached an equilibrium where it's saturated. So it's not necessarily gaining or losing carbon, it's at saturation. And we can induce management changes over time that will either shift that equilibrium to sequester more carbon or to lose more carbon. And this will also be affected by the type of weather or climate that we'll have over the next few years. So in order to really understand the implications that management will have in the long term, we need to include certain things into our inventories, like long-term measurements from these systems, looking at multiple sites that cover different land uses, soils, climates, managements. And we also need a lot of activity data, which is really, really important. So how do we measure carbon sequestration then? So there's a couple of different methods that we can use. The first one is flux towers or eddy covariance towers. And these provide us with continuous field scale measurements of the exchange of carbon along the atmosphere, vegetation, soil continuum. So they operate at really high spatial and temporal frequencies. So these towers take 10 measurements every second. That's block averaged over 30 minutes for every day of the year. And they can measure spatial domains as large as 1 kilometre squared. So you're really measuring emissions that are at the field scale, at the ecosystem scale. So with these systems, in addition to having CO2 sensors, we can also equip them with environmental sensors too. So typically our flux tower setup will have our CO2 sensors, as well as some environmental sensors too, to help us understand how changes in our environment influences our CO2 dynamics. They're also equipped with a 3D sonic anemometer, which will measure your wind direction and your wind speed. And the reason that that's important is because the area over which these towers measure is known as the footprint. And the footprint will vary depending on the wind direction. So in Ireland, our prevailing wind direction is that westerly, but as you can see in this image, that can change day to day and over the course of the year. So we can also use these flux towers as ground truths for remote sensing observations of GPP. So this is your gross primary productivity, or the carbon that's fixed by plants. And previous work has shown quite good correlations between GPP and NDVI in the red zone. So another way that we can measure carbon sequestration is by physically going out and taking soil samples. So in the Teagasc Signpost Farms, one of our researchers, Julia Bondi, is doing a lot of work in measuring our carbon in our farms. So in phase 1 of this massive soil sampling campaign, Julia and her team measured 30 fields per farm for 110 farms, looking at what the baseline of the carbon and the nutrient status of these fields were. And now in phase 2, they're going to be doing work, doing more extensive soil sampling at about 1 metre depth, looking at carbon stocks and bulk density. So where does NASCO fit into all of this? So NASCO is basically a carbon monitoring network that incorporates your flux towers. It incorporates your soil organic carbon measurements from your soil cores, and also looks at remote sensing of our carbon stocks. So NASCO's infrastructure essentially consists of 30 eddy covariance flux towers. And at the moment, we have 25 that are installed. Of these 30 towers, 20 will be on mineral soils, 2 are on organomineral soils, and 8 are on organic or peat soils. So as you can see, they're located all over the country, and they're encompassing different land uses, so grasslands, croplands, peatlands, and different managements, sheep, beef, dairy, cropland. So the soil organic carbon measurement data from the Signpost Farms and the flux data will essentially be used to constrain process-based models that will then help us to quantify the management impacts in soil organic carbon and help us to quantify what the long-term impacts of our carbon stocks will be in a changing climate. So NASCO also has like a remote sensing aspect to it, working with Train AI, which is an SFI, a Microsoft-funded project that's led by Maynooth University, where our flux towers will serve as a ground truth for remote sensing observations of GPP. So overall then, our aims at NASCO are to allow us to better understand the impact of management and climate on carbon uptake and storage, but also looking at different soil types and land uses. It will enable flux data to be scaled using satellite data and using flux data to constrain biogeochemical models, which we really need. We'll also use a combination of the satellite data and the biogeochemical models to extrapolate to sites where data isn't actually available. And these 4 aims essentially help us to build into what we really want to do, which is to refine the national inventory for carbon emissions from land use, management, and soil types. So what does this data then look like? So just as an example, this is eddy covariance or flux data that was taken from Johnstown Castle in 2019 under a silage production system, and in 2020 under a grazing system. So it's a bit of a busy graph, but the main kind of take-home message here is that when we use these flux towers, we can see the implications that management can have on our CO2 flux dynamics. So if we look at the silage production system, if you just look at the solid yellow line, these represent silage cuts. And when we do a silage cut, we're obviously removing biomass from the pasture, and that biomass represents carbon. And when we remove that, we can instantly see a reduction in our CO2 uptake, which is indicated by the negative numbers. Whereas in a grazing system, we don't see the same sharp offtakes when we have cattle coming in to graze the pasture. And that's because in a strip grazing rotation, by the time cattle get to the last strip in that rotation, the previous strips are already starting to regenerate. So we see more of a sawtooth pattern than this really sharp offtake. So the flux towers let us see these dynamics. So another example then is one of our peat sites. So this is in Letterrunchin in County Sligo. This is the Blanket Bog. So with this graph here, the top is CO2 fluxes and the bottom is methane. So we originally put this tower out, James and Rombo rolled it out there last spring. So you can see a few data points at the beginning. We had some power issues. As you can imagine, it's quite challenging to get power out to a blanket bog. So we have a bit of a gap there, but then towards the end of the year, we kind of resolved those issues. And as you can see, for the CO2 fluxes, they typically bounce around an emission of about 5 micromoles of CO2 and an uptake of about 10. So that's normally how the site behaves for this time of the year. But not that long ago, back in April, we actually had a fire event in Letterrunchin, which resulted in a massive peak that's about 2 orders of magnitude greater than what we would expect for this site, at about 600 micromoles of CO2. So to put that into context, that's more than what we're like respiring out in this room. So, with these towers, because they operate at such high spatial and temporal resolutions, we're able to pick up on quite episodic events that you would otherwise miss. But how do you actually calculate the final carbon balance? So with our towers, they're really showing us the exchange of CO2 uptake and release. But there's more to it than that when we're talking about agricultural systems. And so what we want to do is we want to have our flux tower data, but we also need to incorporate activity data. So the carbon that's being imported and the carbon that's being exported from our system. So we have our flux tower data. We might also want information on the carbon that's being returned back to the paddock, be that through animal excreta, through organic fertilizers or slurry, the carbon that's being removed from the system, be that from grazing or harvests, and any carbon that might be leached out of the system too. And so when we do this, we can actually get our net ecosystem carbon balance. And this is basically a graph showing the long-term Johnstown Castle data that we have. That's nearly 20 years. And we can see, the different imports and exports of carbon. And so when we initially look at this graph then, if we're just looking at the NEE, which is the values that the flux towers measure, it shows us a story that in Johnstown, in this paddock, that the system is predominantly a sink of carbon, with the exception of 2018. But this is very misleading because we're not actually accounting for the management effects from our carbon imports and exports. So when we actually include those in our NEE equations, we see a very different story, okay? And so in this period, 2005 to 2008, where the system is now shifting from a sink of carbon to a source of carbon, this is because the pasture underwent a management change into winter kale and was then reseeded in the following year back into perennial ryegrass. And this management effect has caused our system, which was a sink, into a source. But in the years following that, so past 2008, the system recovers itself once again, uptaking carbon. But then in 2018, we have our heat wave. And so when we have increases in our soil temperature, this increases microbial activity in the soil, which enhances soil respiration, which causes more CO2 losses from our soils to the atmosphere. And what this data is really showing is how management and climate play a role in that equilibrium in our grasslands. So just as a summary of that data, in Johnstown Castle, the net carbon balance ranged from a source of about 1.8 tonnes of carbon per hectare to a sink of about 2.6 tonnes of carbon per hectare, but this was driven by land management decisions over this period. The net balance while in winter kale was 1.2 tonnes of carbon per hectare, and a sink of 1.6 when in grass. But regardless of the management, you can get a really bad year. You can get a bad drought. You can get really hot temperatures in your summer, and this can shift everything altogether. Where the system was transitioned into a source in 2018 at about 1.38 tonnes of carbon. So what can we expect then from NASCO in the future? We can expect that we'll be monitoring a lot of long-term changes in our soil carbon stocks in response to management, soil, land use, and climate. That this information will then be used to improve our national inventory. So we'll step away from our Tier 1 emission factors and we'll have more Tier 2 and Tier 3. And this data will then be used to help policymakers make science-based decisions around climate change policy. So I'm just going to leave it there, folks, but I just would like to acknowledge the different projects. So, for example, NPWS, Curbstall, Vista Milk, to name a few, Train AI, as well as my other PIs. So, Matt Saunders, Gary Lanigan, Carl Richards, Conor Bracken, as well as the technical staff too. So, James Rambo, George Bishop, and Jack Bishop, George Gleasier. Yeah, thank you.
Thank you very much, Rachel, and I'm sure you mentioned all of the names there, so well done on that. And you have shown us the sort of value of these sort of detailed measurements in understanding the carbon cycle and balance in our soils. And we're now going to go on to a very specific high organic soil type, our peatlands, and our work to rehabilitate our peatlands. So I'm delighted to have Dr. Mark McCorry, who's Head of Ecology and Bog Rehabilitation for Bord na Móna. Mark, the stage is yours.
Thank you, Frank, and great to be here. And great to talk a little bit about what we've done the past few years. I'm hoping that, metaphorically speaking, I'll get your feet wet over the next 20 minutes. I would like to acknowledge the comments of Minister Ryan, very positive in relation to Bord na Móna. We think about the first climate action plan. I know it didn't have that name. I was doing a bit of reading, and like back in 2019, like one of the actions in that was that we had to stop burning peat for energy, and that has happened. Bord na Móna has ceased industrial peat extraction, and sure that has allowed us to increase our peatland rehabilitation ambitions at a massively increased scale. So, look, you know, why we rehabilitate peatlands. Look, I know probably everybody knows this, but sure, peatlands are really good stores of organic carbon. Like it's estimated nearly 30% of soil organic carbon is in peatlands, but it only covers 3 to 5% of the land surface. So more carbon than any other terrestrial ecosystem. And I borrowed this graph from a colleague, John Connolly, a few years ago. But that bar graph on the right-hand side, it compares peatlands to rainforests, and you can see much more carbon in the peatlands. So we know, and it's been discussed already, if peat is dry, it releases carbon to the atmosphere. And we know rewetting of peat can reduce emissions of carbon. So if we look at this graph, again, I've borrowed this from colleagues from the Gresfeld Mars Centre. That shows carbon emissions and the correlation with water depth. And what we can see is, in terms of drained peatlands, the deeper the drainage, the more carbon emissions there are. So if we reverse that, if we move down that green line towards what we would call the Goldilocks zone, around 0, which is the peat surface, that's the sweet spot for peatlands in terms of reducing carbon emissions. And we can improve bog condition and turn those sites into really good carbon stores. And then if they're in a really good condition, they can also sequester carbon. That means obviously the sphagnum mosses are growing well, and they can do this over really long periods. So this is why peatlands are so important. So then, just like we've heard some of these numbers already today. Obviously, we know land use change could potentially add 7.3 million tonnes of carbon or CO2 equivalent to our inventory. We know it's a key source of emissions. We know peatlands is a significant carbon source because a lot of our peatlands is degraded. Peatlands are 20% of our national area. Gavin was very good at trying to explain the difference between land cover and peat soils. Obviously, on Bord na Móna lands, we have native woodlands or natural woodlands and some peat. So it's very important to understand those dynamics. Interestingly, Bord na Móna only owns 7% of peatlands in Ireland. So there's a lot more peatland out there that needs to be brought into better condition. In terms of the Peatland Climate Action Scheme, this is really ambitious for Bord na Móna. It was enhanced rehabilitation of 33,000 hectares across potentially 2 bogs, very much supported by deck, and I'd really like to acknowledge them in terms of helping us. And Jim talked about just transition earlier on. This is really important for the Midlands, obviously for Bord na Móna staff. And we got going in 2021, and we were working very closely with our colleagues in the National Forest and Wildlife Service who regulate the scheme. And again, I'd really like to acknowledge their input and support over the past few years. So, why do this? Again, and again, this, comes back to, even ongoing chats and conversations with people and experts over the years. And some of the colleagues that came from the UK and Scotland, they came over to Ireland, and we showed them what we were doing, and they told us, oh, you should be doing a lot better. And again, we looked at that, and that's where we came up with these enhanced measures. So really trying to optimize the climate action benefits, really trying to optimize the re-wetted footprint, and create these soggy conditions, this Goldilocks zone where we're minimizing carbon emissions. So what are our targets? And this is where we really delve into the detail or get our feet wet. And this is where ecology becomes important. For a lot of the deep peat and the deeper peat that are left on Bord na Móna lands, we want to get that into as best a condition as possible. And sure, that means getting sphagnum growing on it. And we know sphagnum will grow on it. This is a key peat former if the hydrological conditions are right. So that's where the focus is really on trying to get these water levels right. If it's slightly too dry, then we have a lot of heather and a lot of scrub development, which is when we look at the specific emissions from that specific community type is a carbon source. So the more we can get into a better condition with lots of sphagnum, the better for these peatlands. But a lot of Bord na Móna peatlands have been in peat extraction for 50 plus years. The majority of peat has been removed away, and those peatlands are in significantly different environmental conditions. So the outcomes for those peatlands are going to be quite different. We won't be able to grow those bog mosses that sequester carbon, the sphagnum mosses on these peatlands because they have alkaline groundwater influence, and that's where the best outcomes here are re-wetting those residual peats and developing fen habitats, developing reed swamp, developing wet woodland. And again, this will be the best outcome for climate action, a reduced carbon source. And if you think about some of these images here, these are all bare peat. And this is a response of rehabilitation, of re-wetting, and of natural colonisation. So again, just to explain, some of the challenges we face. This is Edra Bog. This is an aerial photograph. This is the LiDAR map. This shows topography. The blue, it would be the higher ground. The orange would be the lower ground. So this is really good, really important for us to plan peatland rehabilitation and plan different measures in different places. This is peat depths. Obviously, in some of our bogs, we have variable peat depths, and it's very important to understand those peat depths because, again, we design different measures in different areas for different outcomes. Hydrological assessment is very important, and we do a lot of new hydrological assessment to look to see what can be re-wetted relatively easily, what can be re-wetted with a bit more difficulty. And again, if we just blocked up the drains at Edra Bog, those blue areas would be the areas that would get wet. So the remaining areas would be in a drier condition. So again, just to show some of the machines on the ground, and this was really exciting for me. Like if I think back about my career in Bord na Móna, 10 years ago, we had one machine carrying out peatland rehabilitation, restoration. Now we have, maybe 65 machines, excavators carrying out these activities. Just to talk about some of the really intricate hydrological assessments that we're doing at the moment. Really important to understand water flows in terms of trying to get hydrological conditions restored again. So we put a lot of thought into design and planning, in relation to drainage plans. Obviously, with variable topography, this can be a real challenge. But this, this is, in terms of a change in magnitude, this is beyond anything we were doing, 5 years ago. So doing a lot more analysis of the hydrology and the drainage of these sites. And this is very important for risk assessing what we're planning to do. We're obviously very conscious. We don't want the impact on our neighbours' land. And we want to make sure we're designing measures that isn't going to have unintended consequences. An example of that would be where, on occasion, we do have water flowing into our bogs. We don't want to block up that water so that we're holding water on adjacent farmland. And so we do compromise where required, allow that water to flow through our sites. We don't block up boundary drains, for example. We don't, and in some cases, some people still have turbary rights on board Namona lands, and we can't affect that either. And again, this is an example of Derry Brat Bog. You can see it's been re-wetted, and you can see the farmland around the periphery. And again, that's an example of a bog that we have re-wetted quite successfully with no impact on the surrounding land. We do a lot of stakeholder management as part of the scheme. And again, obviously this started during COVID. It was very much online at the start. But again, compared to what we were doing a few years ago, even 5 years ago, one of the things we're doing now is knocking on all the doors around our bogs to, to tell people, talk to people about what we're doing, talk to those landowners. We just didn't have the resources to do that 5 years ago. So again, this is very important for, again, getting the message across about what Board of Mona are doing on their lands and trying to ensure that, we're communicating in the right way with our neighbours and trying to resolve any issues where needed. This is our progress, and again, so far we've re-wetted, rehabilitated over 13,000 hectares, across 38 bogs. These numbers, sometimes it's hard to really understand them. If I think about our first biodiversity action plan, Board of Mona, we re-wetted 500 hectares over 5 years. That was 100 hectares a year. So in terms of the change in ambition, change in progress, change in delivery, it's been phenomenal. Just one of the things I wanted to mention was obviously re-wetting takes time. Changing these bogs from brown to green. We do depend on natural colonisation, and a lot of what we've seen in the past has been from natural colonisation. But now we're starting to look at other solutions, and one of these would be inoculation of seed or plant materials. And again, just over the past year, we've started doing some sphagnum inoculation at Umbers. And the experts who tell us that, if you get the conditions right, the sphagnum will come to these bogs naturally. But here, what we're trying to do is we're trying to speed that up. Can we do better? So we very much want to try to improve conditions and speed up the trajectory of improvement at these sites. This is just an example of Castlegar Bog, one of the bogs where we started. It's a great example of some of the works. And again, you can really see the contrast between the wetted areas and the areas that have not been targeted at that time in terms of the darker wet colours and the paler areas where the drainage is still intact. This is just an example of a different type of bog. I tend to talk about peatland rehabilitation because the majority of Bord na Móna bogs won't be able to go back to raised bog in the short term. But this is an example of where it can. This is a bog that was drained but never extracted. And here, once we get the hydrology right, again, there's great prospects. And like just amazing for someone like me, that there's 5 diggers in this picture, all working on peatland rehabilitation. So that was 2021. This is it in 2022. And again, you can see the change in conditions, water levels at the surface of the peat. By doing this work, okay, we've obviously locked up carbon in that bog. But in terms of our EU Habitats Directive, like we modelling that there's potentially 25 hectares of Annex 1 active raised bog will be able to develop on this particular site in the near future. So again, once you get the conditions right, the bog can respond relatively quickly. Obviously, there's a lot of monitoring being done as part of this, and again, if we think about LULUCF, important to understand what we're doing in relation to carbon. If we think about some of the original estimates that we did at the very start, and again, appreciate we were using tier 1 emission factors at that time. And various different metrics that are obviously changing, and it obviously ensures the importance of continued monitoring and continued understanding of how the science is changing here. But we estimate, the PCAS would support storage of 75 million tonnes of CO2 equivalent carbon by re-wetting the residual peat, and then avoided emissions of 3.3 million tonnes of carbon equivalent and CO2 over 30 years compared to the do-nothing scenario. So, obviously, this is where we win in relation to climate action. Just in relation to some of the other monitoring we're doing, we do a lot of hydrological monitoring. This is very important in really showing the short-term effects of the rehabilitation. And we can see the changes in water levels in these graphs. And again, there's a yellow line up the middle of that graph, and that shows when we started some of our rehabilitation at this particular bog. And it shows that we're getting immediate results at that bog. And again, it's really about getting those results and then being able to fine-tune the water levels so we're in that Goldilocks zone of water levels there or thereabouts at the peat surface. We do a lot of biodiversity monitoring as well, and again, I could talk for the rest of the day about biodiversity on these bogs, but just to call out a few different species, like we have red shank starting to breed in some of these sites. Red shank is a red listed species. It's a ground nesting wader, very scarce, but here it is at one of our bogs. And again, this is an example of a bog that would have been brown 10 years ago. It would have been in peat extraction. So just moving on to some of the other work that Bord na Móna are involved with. Bord na Móna are assisting MBWS in terms of bog restoration on some of our raised bog SACs and NHS. Again, you can see some of the complex bunding and complex drain blocking that's been carried out, and this has very much been led by MPWS on our protected areas. This is on state-owned land, and it is on private land as well. And Bord na Móna have played a big role in terms of landowner liaison, in terms of talking to those landowners and users of those bogs, in terms of being able to get progress in terms of re-wetting. We're starting to do some work on blanket bogs as well. So we're starting to look outwards. And this is going to be particularly important in the next few years. Bord na Móna have developed a lot of expertise and skills and knowledge in relation to peatland rehabilitation and restoration, and we hope we'll be able to help Ireland in terms of achieving its targets. This is an example of Blanca Bog out in County Mayo. It's part of the Wild Atlantic Nature Project, Tullagan and Shammer Bog. You can see the drains are unblocked there. We are developing a restoration plan to get in and to block those drains, hopefully in the next year or so. And again, important to touch off Bord na Móna strategy in general. Like obviously, if we think about our climate action plan, it isn't all about LULUCF, and it's not all about rewetting peatlands. It talks about renewable energy as well. And Bord na Móna have very much moved into that space, looking at renewable energy. And we want to roll this out across our cutaway bogs, not all of our cutaway bogs, but we do have a strategy of integrated land use. And that's where we need to then think about the win-wins or the win-win-wins in terms of integrated land uses, and really trying to optimize the benefits and try to minimize the negative impacts in terms of developing this infrastructure. So just to finish, just in relation to LULUCF, and again, I was struck by some of the conversations on the radio over the past few weeks, and I pulled this off just the AgriLand website. It's great that rewetting is being talked about on the radio, but we do need to achieve balance here between the various different needs. Sometimes conflicting needs. Okay, we need to, we really need to deliver for land users, landowners, communities, and the climate action plan. So then we need to think about our communication and our language. I'm sure as policymakers and as practitioners, we need to do that as well. We need to get better, but we still need to deliver at scale. In terms of meeting the challenges of delivering on the targets that have been discussed already. So look, I put together, I played about with PowerPoint yesterday, and I put together this, and again, one of the things that struck me just since the radio was, some of the politicians talking about, well, they don't know what rewetting is, and one of the issues is we're not very, we need to be more careful with our language, and for some of these words, if we talk about reactivation or revitalization of peat, okay, that could be the starting point. That could be where we rewet a field, but that doesn't mean the land use has to stop on that field. I think that's the key point I want to make here. So as the water level changes, that's going to support climate action. And there was a very useful study came out a year or so ago that demonstrated that for every 10 centimetre change in hydrology, you can save 3 tonnes of CO2 equivalent emissions from that from a hectare. So even if we raise the water level a bit, that's going to have a positive impact. And then we can go all the way to peatland rehabilitation. And restoration. So obviously restoration is restoration of Blanca bog habitats, restoration of raised bog habitats, restoration of the processes as well. So just to finish, for me, rehabilitating peatlands absolutely makes sense. It works. But my colleague Shane Regan in MPWS did want me to make the point that it does take time. But I've been lucky enough, I've been privileged in Bord na Móna, tramping across these bogs for 13 years now. And I've seen sites going literally from brown to green. I've seen the biodiversity coming back. And for me, that's been very positive in that it shows if we do the right things, nature will respond. Like we know the metrics are bad, the EPA metrics are bad, MPWS metrics are bad, but again, just to leave on a positive message, again, if we, nature can respond and we can do a lot of positive things if we do the right things. Thank you.
Yeah, thank you very much, Mark, and thanks for ending on a positive note there. I think there's a great story happening with our restoration of peatlands. So I'd like to invite all of the speakers up on stage. We have just about 20 minutes for Q&A, so I hope you've been saving up your questions, and we'll get some answers. So I think, first of all, thanks to all of our speakers. They've done an excellent job. We've gone from global to local to very local to peat bogs. And over that, I think what we're showing is the amazing amount of information and data that we're getting. I suppose I'm thinking of going back to the inventories. I suppose a question from my side is, how close are we to that tier 3 sort of nirvana? But I'll leave that with the panel till the end. What I'd like to do is to open the floor to questions, and I see there's a question up at the front here. I think it's Professor Convery.
Hi, Frank Convery, UCD. Thanks a million for a really terrific session. Just a few quick questions. One is just language, and I noticed that the Commission, European Commission, seems to use carbon removal as their language of choice, and we talk about sequestration. And I'm just curious about if there is a difference and where we're going to likely land on that front. The second, which is a question, is the kind of macro picture that I see the evidence here in 2 phases. One is it forming much better macro data on removals. And the second is the commitment by the European Union to provide farm-based data on removals by 2028. And obviously, that's crucial for policy to have farm-based information to reward performance and so on. So I'd be very interested in the panel's views as to where we stand in terms of, say, evolving the Teagasc's wonderful sustainability reports, where we have data by farm system with, variations and so on emissions, but we don't have data on removals in their data at farm level. So roughly, we have a date of the Commission, 2028. We have the work that's going on with soils, with forests and so on. Are we likely to get there in time, so to speak? So can a farmer expect to know or be able to know what both their emissions and their removals are going to be in 2028. And my final question is about costs. And this goes to Eamon's question about mapping as well. What 3 years from now for the new maps rather, what will the cost be of redoing it every 3 years? And similarly on the removal/sequestration, how much does it cost to get to there? Thank you.
Okay, thank you, Frank. I was going to ask for further questions, but I think you've asked 3 questions there already. So I'll quickly, and I do see a lot of hands going up there, but I'll ask the audience just to respond to those 3 issues. Who wants to start?
Sure. I might just say just a few things on language. Like my own experience within Board and Mona, this has obviously challenged us. Some of these terms around carbon sequestration, carbon storage, like sources and sinks. And, we've worked, I'd like to say I've worked with my senior management to drum it into them that not all our bogs can, start sucking carbon out of the atmosphere, in the next few years, in terms of the sequestration. So this is really important, and again, as the science changes, we have to adapt to that. And then we also have to get better in terms of trying to communicate that as well.
Eamon, would you like to add something?
Maybe just as well on a related point to the sequestration and the removals. I think there's a misrepresentation sometimes of stocks as well. It's something I encounter a lot, that the sequestration is the ongoing removal of the rate of change, whereas the stocks, like our peatlands, even some that are degraded, still have very significant stocks in them. But in the inventory, we're looking at the rates of change, and that's quite important when people talk about things like carbon farming and so on, because that would be reliant on additionality, and that's another term, but yeah, I think so. That's quite important as well, to bring stocks into that, I think.
Rachel?
Yeah, I could take the point on cost. I wouldn't have a monetary value, but it's just to say Tall Chairn are mandated to collect imagery on a 3-year cycle. So a lot of the data sets that we inputted into the map, we already have. Our imagery, our height data, and Prime 2. So it's just taking that data and kind of analysing it and taking it a step forward to create a new map. We have all our processes in place. We've able to train the AI, like the machine learning algorithm, so we do hope, like in our next iteration, that the turnaround time would be a lot less, so therefore wouldn't cost the same.
And Rachel, would you have anything to say about the farm scale issues?
More really on the terminology, because I think you made a really good point there. Like carbon sequestration is obviously taking carbon dioxide from the atmosphere and fixing it into soils and vegetation. And when we talk about other sources of removals or emissions, that's not carbon sequestration. They're imports or exports that are added to your carbon balance. And you were saying that in the EU they have different terminology for these different terms. And I think as Ireland now moves towards ICOS, we need to start aligning our language more so there's more clarity and there's less confusion.
Gavin, do you want to add anything?
Not a whole lot to add. I suppose just I wouldn't say we'd, like, in terms of like emissions and removal at a farm-based level. Obviously, that would be I would say a policy decision to do that. But if you actually look at the type of data we're now collecting and getting closer to, from the spatial data to the data that's coming from the soils mapping and so forth, we're moving towards a better place that you could do that. But whether and when that happens, I couldn't answer that.
Yeah, thanks, Gavin. And I would add, I suppose, in the Paris Agreement, we are looking to achieve that balance of greenhouse gas emissions and removals. So removals is very much policy speak, while some of the other words are very much on the science field. I see a hand at the back, a hand halfway down, and a hand at the front. So I'll ask the microphone. Yes. Please identify yourself.
Just a really quick one. Dr. Haughey spoke earlier about having some really good reasons why agriculture and LULUCF are separate. Obviously, that's a huge concern for the farming industry, because agriculture, consisting of pretty much livestock and fertilizers, does not have the capacity to exist and reach net zero while separated from the land that we farm. So I'd love to have some clarity around the really good reasons why those are separated.
Thank you. Next question, please. Okay.
Hi, Cara Augustenborg, UCD. It was really great to see such evolving science. I remember starting my PhD when the Korean land cover mapping was happening, and it's great that we can now have better decision-making support tools. So my question is really about a concern about the timescales, because obviously the climate crisis is urgent. Our first carbon budgets expire in 2026, and the timescales of some of this science looks like it's quite a bit after that, and some of the data we're using is 2018 data. We know that land cover has probably changed a lot in that time, so I'd love to hear from some of the panelists how they think maybe we could inform policy sooner rather than waiting for these things to run their full course before we start using them. Thank you.
Okay, yeah, there's a question on the front here, and yeah, please, if you come to the front, and then we'll go back. We'll try to get a next round of questions in, and if you could make the question short.
This is you, Frank, more than anybody else. We just had a lady talk about urgency. This whole, I mean, we're sitting here in a nice, cool conference hall in a nice May day. in Dublin as if nothing else was happening in the rest of the world. But I'd like to thank the people on the panel for actually giving very good, very solid scientific facts. How and what is the plan to get these facts into just transition so that we can actually move this along urgently, because that urgency doesn't seem to be here? How do we do that? How do we bring the rest of the country on board to actually understand that actually what is being proposed is good things?
Thank you for that question. I'll ask the panel to deal with the I think, Eamon, was a very specific question to you.
Yeah, so on the LULUCF and affluent, and I'm going to bounce this back to you in a second, Frank, because I think you could shed some light on this as well. If we're looking at how we get to net zero, it will be much easier to get to net zero within LULUCF on its own separately, because obviously agriculture is a much larger source than LULUCF is at the moment. So combining them does not improve the picture in Ireland. That's not the case in other countries where they have large areas of forestry, for example. So if they combine them, it actually can balance or bring close to balance their agriculture sector as well. So that's just a sort of a nuance in that. But when it comes to why they're separate, I think that goes back to maybe the Kyoto Protocol, is it, Frank? Is that correct? Yeah, and how the inventory, the accounting systems were set up at the time. I don't know.
Yeah, no, it's part of how the Kyoto Protocol established the LULUCF sector, and it has been retained. But within the IPCC, as Jim has said, there's a tendency to look at the integrated land use and agriculture issues, and indeed that's the IPCC in their good practice guidelines have an AFLU sector, which is agriculture, forestry and other land use. So scientifically, yeah, you have, I suppose, more understanding of the need to have an integrated approach, but within the policy sector, you need to actually understand how much you are removing or sinking, and then you need to understand your emissions as well. So there's a good reason in that sense to know what you're putting into the atmosphere, what you're taking from the atmosphere. And as we've also said here, much of our land use in Ireland is actually an active source. So what we need to do is to get the land sector, regardless of how you call it, to net zero as soon as possible. And as Jim has said, that's the first step in actually that pathway to climate neutrality. Sorry for that long intervention there. Gavin.
Yeah, Frank, just to come on the repeatability of maps and the urgency, I suppose just to kind of emphasise, we came at this in 2018, ourselves and Táil Éireann, we really didn't know exactly how we were going to do it. So there was about 2 years of trying to figure that out and get that exactly right. Once we got our processes in place, it all happened much faster. So from talking to Táil Éireann, their aim is to fly the country, I think it's 1/3 per year, and then basically map it as they get that information through. And the second part of that is I wouldn't just limit it to this specific mapping. There's a lot going on in other areas in terms of mapping, and it's trying to bring all those things together. So there's land mapping activities under the Copernicus programme, where there's data coming out nearly on a monthly basis on phenology. They're doing regular updates of 3 years on different types of data. So within the EPA at the moment, we're actually doing a project where we're trying to look at all the catalogue of data that's coming out from the Copernicus Land Monitoring Service and how that might actually be applied in Ireland. And then separately to that, we have the LULUCF processes going on where we're trying to basically map out the use underneath the LULUCF categories every single year. So it's not that we will just be depending on 2018 data.
Okay, and just on your question, just so that's a policy issue, but I think if you look at the policy cycle, we've shortened the cycle from a 5-year cycle to a 1-year cycle. So the urgency is absolutely understood within the policy arena, and I think the Minister articulated that at the start of this event. So last 2 questions. We're in the last few minutes. There's a hand in the middle, and I saw a hand over there. So.
Sorry, I'm over here. Isolde from Natural Capital Ireland. I was just wondering if you could talk briefly about how the land cover map can support the creation of an ecosystems map, I saw that it was, it's there on the slides as being something that is of high use to developing an ecosystems map so that we can support us in our ecosystem services accounting responsibilities that we have, and then also to mark just about how an ecosystems map can help in the work that we're doing around conservation.
Okay, question there, and then a question here in the middle.
Thank you. It's Jula from Trinity. And my question is also about the mapping, since like from the forestry statistic, Ireland forest coverage is 11.6%, and the target is 18%. But now, like according to the map, is already meeting the target. So is there any policy indications or next step planned, like from the policy perspective or for people doing research in this field? Like what's the guidance for, is there any guidance or next step? Yeah, thank you.
And a final question from just here. Please keep your hand up until you get the microphone.
Yeah, I'm Ina Kelly, public health doctor in the HSC, and I'm just really thinking about the public health impacts of all of this, because in the end of it, really, climate change is a concern for us, mainly because it impacts on people's lives and health. And we're not really hearing, and it's not, this is a fantastic presentation, all the presentations are fantastic, and it's wonderful learning for us here in public health, but I'm just wondering, maybe some of the analysis and the policies need to include the health impacts too, because the balance between the win-win-wins, which we really, really want, and then of course the other issues like justice and where people are going to lose, maybe will lose unless we invest in those areas, just need to be considered as well, or maybe if you have any thoughts on that, including like things like air quality can improve through some of the land use changes, so can water quality, and something that isn't often mentioned is microbiological water quality, because that's actually where we see the illnesses. So just if you maybe consider that as well, thanks. On mental health, mental health of course is really important. of losses, I mean.
Okay, thanks Ina. And so we're talking about ecosystems, we're talking about maps, and then we're talking about the multiple benefits. Who wants to start? Gavin, do you want to?
If you want to go on.
Sure.
You go first there, Mark, sorry.
Just to Isol's question about, ecosystem mapping and understanding, natural capital, how that can help conservation, if I got your question right. Like, it's really important because our landscape is changing. We need to understand, where our habitats are. We need to understand what condition they're in and how they're going to change over the next few years. What's interesting, if I again go back to our Bordemona bogs, some of these bogs are, and the habitats developing on these bogs are changing quite quickly. Just yesterday, my colleagues were down in Lollymore doing some vegetation mapping of the birch woodlands that are developing there. They found wood sanicle in that birch woodland. Why is this important? Like birchwood or wood sanicle is an indicator of old woodland. So this birch woodland, it's only 40 years old. So again, like this is a surprise to us, and it's just an indication of, the more we look, the more we see, the more we're going to learn about these sites. So monitoring is vitally important for conservation. And just to finish, like obviously we've been talking about peatland rehabilitation. We also have to think about the habitats that are in relatively good condition and also maintain those habitats in good condition, and think about the people that are maintaining those habitats in good condition as well.
Eamon, I think there was a specific point for you there.
On public health, I think, so this would have been touched on a little bit in the special report on climate change in land around food. And that certainly looked at health and including the whole food system. So I think a food systems approach is something we haven't really seen in Ireland when it comes to climate change, and maybe that type of analysis will be beneficial in the future. I think in terms of the mental health one, and this touches on, I think, something Laura mentioned this morning about how important local wildlife or natural areas were to us all when we couldn't move very far from home. And maybe that links to this idea about what type of landscapes do we want to live in the future, urban and rural in Ireland, and be that north, east, west, or whatever part of the country you're in, the type of landscapes people want to live in that will be healthy for them, have amenities they want to have close to them, and also provide incomes for people. And I think this sort of integrated approach will have to include public health as well, along with biodiversity and water quality. It makes complete sense to try and bring that in. It makes it even more difficult probably to do the integrated assessment when you do, but obviously it's really, I think, important. Yeah.
Just to add to that, like there's loads of metrics that do show that, like if you think about mental health, that you know having a walk in a green space, improves your mental health. And like I know myself, in terms of mindfulness, getting out onto these Galway peatlands is my mindfulness. And so I would recommend everybody to go and visit Lochmore Discovery Park over the next couple of weeks. The orchids are coming out. It's a beautiful spot.
Thank you for the advertisement there. Rachel Chagas, have you anything to add? Final points or
Yeah,
comments?
I guess just in terms of monitoring like your air pollution, I think that kind of came up. So obviously in the NASCO network, it's more focused on your emissions from your agricultural soils. But there is work being done on monitoring air pollution, particularly in NUIG with Damien Martin's group. So that work is being done, and I guess linking that with mental health and whatnot would probably be, there's probably a gap there, right? In terms of mixing the physical science with the social.
Rachel and Gavin, then, is there any?
Yeah, just to say, this, talking about the mapping element, it's the first iteration of many, and it's the first time kind of a map of this scale has ever been done. So now that we know where everything is, we'll be able to kind of see the evolution of the land cover over time as more and more iterations come on board to help with, ecosystems mapping and habitat mapping in the future.
So Gavin, Tier 3 and...
Oh God. Well, I'll address a little bit quickly on the ecosystems service mapping. So the National Land Cover Map is not an ecosystems map, but and when we sat down years ago, there was a big discussion about whether we were doing a habitats map or a land cover map. But land cover was ultimately the first step, and at that stage, we really thought that the land cover could then give us an indication as to where we should be mapping in terms of habitat mapping. So there are projects. We have a research project at the moment with John Connolly that's in its last year, called iHabimap, where they're going in with drones and trying to identify habitats and species using much more detailed information. So ultimately, it'll be more indicator towards ecosystems as opposed to ecosystems mapping. But ultimately, it'll be using ecosystem accounting by the CSO because it's the most complete national information that could feed into that. And then on the forestry stats, as I think someone said once before, stats and dam stats, I'm sure there's people here from the NFI perspective, the definition of a forest can be quite different. And what we've called forestry or trees, we've things like hedgerows in there, which wouldn't necessarily get covered in the NFI as wouldn't meet the definition of a forest. So we have to be very careful around that, and we have to do more exploration into understanding exactly what that stat is and kind of divide that out and maybe link it back to the NFI. So I wouldn't say that we're there already. It's actually we need to look into that a lot more to really understand what change there is in terms of national forestry under that category.
Yeah, and I think, as Mary Frances pointed out, all of the data are retrospectively put into the inventory back to 1990. So the change, I guess the change would be a relative change in terms of...
Did you want something on Tier 3 or not?
Have you got a...
I suppose a little bit. Just it's around. I think Mary Frances put up a graphic which really talks about Tier 3 in terms of spatial data for the LULUCF process, and then I know Rachel, you were talking about the same on the modelling side instead of just the standard figures that go in. So I won't cover that because that's not my expertise. But on the spatial side, we were moving very close to having spatial data. We've already mapped it for a number of years under the LULUCF spatial data mapping project, and our aim is to try and get that across a 20-year cycle, if not more, and then do it into the future. So we're not actually using that data yet. We're actually just preparing it and getting it in place, but we are moving towards that over the next while.
Great. Thanks, Gavin. And I want to reiterate the point that was made. The EPA research call is open. I think we've heard a lot of areas where we need to enhance our information. So use the opportunity to put in proposals while the call is there. And with that, what I'd like to do is to close this session. Thank our speakers again for really excellent presentations and for sticking on time. I think I'm the one who's dragged it over time at the end. But okay, enjoy your lunch.